Hello, we're going to be doing conic sections again. This is our last of the conic sections. We're doing hyperbolas. This is section 10.4. Let's get started. What is a hyperbola? A hyperbola is a set of all points so that the difference of the distance between a point and two foci is constant. Last time we had an ellipse. Last time this word was sum instead of difference. That's the only thing that's changed between hyperbolas and ellipses, except obviously the shape, but the definition is the same. When we subtract them now, they're going to be going apart instead of coming together. Here's one side and two sides of our ellipse. This definition states that if I have a distance from the foci to one point of the hyperbola to the other foci, that D1 and D2, if I subtract them, I will have the same number every time. Let's go over some vocabulary. You have some note sheets. Get your note sheets out. This one has a center at 0, 0, and the transverse axis is horizontal. Let's understand what that means. This is now called the transverse axis. That's the one that goes through both of the hyperbolas. On your note sheets, I would get it out and I would actually highlight that transverse axis so you know what it is. Maybe even put a little arrow with it. Here is the equation that goes with a horizontal hyperbola. A horizontal hyperbola has the x value first and the a value first. That x value first indicates that it is horizontal, and I like to think of it as it's actually on that x-axis. We will be shifting things around so it won't necessarily be on the x-axis, but it'll be on a horizontal axis nonetheless. That a value that we're talking about here is the value from the center to one of the vertices. Here, that is here. That's the distance from the center to the vertice. I want you to notice that the vertice actually touches this hyperbola right here. That is the same distance from the center to the other hyperbola. Right there. We have a b value, and that b value is under the y, which is under the vertical axis that goes through, does not touch the hyperbola at all, and that b is the distance from the center to a box that we will draw in a little while. The c value is the distance from the center to the foci, and we have foci on both sides. We have an equation that helps us find our asymptotes, and that's y equals plus or minus b over ax. I prefer not to memorize this formula at all. There's two methods. We'll go over one of them later, but the first method that I prefer is that this asymptote right here is just in a line. And this is an equation of a line. This is just the slope. I would suggest that you actually write the word slope right here on your note sheets. That b over a is just a slope. And it's the rise over the run. We have a rise right here of b, and we have a run of a. So b over a is our slope. We have one last equation that's pretty important. This is how the a value, b value, and c value all relate to each other. So if you know the a and b value, you can find the c value, which is your foci. So this is the equation to help you find your foci. This equation will not change for the horizontal and vertical hyperbolas. Now let's move on to vertical hyperbolas. A vertical hyperbola has a vertical transverse axis. That means that the vertical line of the axis will go through the vertices. In this case, this is the y-axis, because our center is at 0, 0. The a value is still the distance from the center out to the vertices. The C value is still from the center out to the foci. And the B value is still up to that box, which we're going to talk about in a little while. I want you to notice a difference in the equation. The equation has a y at the beginning instead of an x, but a is still at the beginning. A is always at the beginning. The way I remember it is, since the y is at the beginning, it goes across the y-axis. Even though we're going to be moving it around a little, it'll still be on a vertical axis. Our asymptotes now have a new equation. I would suggest that you write this down, but this slope can be found a different way if you do not want to memorize that formula. That slope is for the asymptote, and it's still the rise over the run. The rise is, in this case, the A value, and that run is the B value. Hence, the slope A over B. We still have the same equation that relates the A, B, and C values together, which is the Pythagorean theorem. Let's graph the hyperbolas, and I'm going to give you a step-by-step instructions on how to graph these. As I go along, I suggest you actually write these steps down. It's going to be very helpful. First, you're going to plot your vertices and your co-vertices. Your vertices are the A values, and your co-vertices are the B values. That's the edges of that box. And those are found on the bottom of your equation. Your A squared is your vertices, and your B squared is your co-vertices. Then you're going to draw your box. Once you have your vertices and your co-vertices, you take your ruler and you just draw your box. This box is going to be super helpful in drawing your asymptotes. That is the next step. You're now going to connect the corners of your box. Your corners are at your box, and you're going to take your ruler and you're going to draw your asymptotes. Your asymptotes will go through the center and the corner of your box. This will then help you draw your hyperbola. And that's the next step. You need to notice that you have 4 places to draw your hyperbola. We have the ones that are drawn here, but you could, if you didn't know any better, it's possible to try to do them over here. The way you know that they're an up and down parabola is on your equation, which one comes first. If x comes first in your equation, you're going to draw them side to side, or left and right. If y squared comes first, you will draw them up and down. Let's actually do one. The one we're going to do, we're going to identify the vertices, foci, asymptotes, and the direction of opening. We're going to do number 1. We're going to look at our equation here and look at these values here. I suggest you have your note sheet out and notice that the A squared value is always there and the B squared value is always there. That means that A equals 5 and B equals 2. This helps us draw our box. This helps us plot our vertices and our co-vertices. That's the number 1 step on your list. If A is 5 and Y is listed first, we're going to go 5 on the y-axis. X is listed next, and 4 is under it, so we're going to go the square root of the 4, which is 2, on the x-axis. Now we will draw our box. You can use your ruler or not. And then we can draw our asymptotes. That's the next step. Our asymptotes should go through the center and through our corners. And now we need to decide which direction our hyperbola goes. Does it go up and down, or does it go left and right? We look at what's listed first. It's the y first. Since the y is listed first, it is over the y-axis. So this is an up-down hyperbola. That answers this question right here with the opening. We're going to write that it is an up-down hyperbola. Now let's do the rest. Let's do our vertices. We have two vertices. We have one right here, which is at 0, 5. We have another one right here with 0, -5. You can write it as two ordered pairs, or you can write it as one at being 0, plus or minus 5. Let's now do the foci. We're now going to find our foci. Our foci are related by a formula. If you remember, that formula was the Pythagorean theorem, a squared plus b squared equals c squared. Our a and b values are right there, and we could have just found them from our a squared and b squared values right there. So we have 25 plus 4. We add those together to be 29. So c equals the square root of 29. So that means we're going to go up square root 29 and down square root 29. So you're going to need the value because we need to mark those on our graph. So go pause this and get your calculator out and take the square root of 29. Square root 29 is about 5.4. So I'm going to come in here and I'm going to go 5.4. And the 0.4 is really close in there to what it's really close to 5. I'm not going to be able to see it very well. Might pick a different color. It almost looks like 6 on mine. 5.4 is about right there. There we go. All right, but let's list our foci in here. It's going to be 0, since we went both up and down square root 29, we're going to do the plus and minus square root 29. Now our asymptotes. Our asymptotes, there's a couple ways of doing this. First of all, remember we can do the slope method. You can do your formula method. I'm going to do the slope method real quick. I've got this distance here is my a value, which is 5, and that distance there was my b value, which was 2. So it's 5 over 2. We always list it as an equation of a line, y equals. We always do the plus and minus because we have two asymptotes on this side and on that side. It was the 5 over 2 x. Now, the other way to do it is this is the y, this was the number under the y, and this is the number under the x. So, it's always the square root of the number under the y divided by the square root of the number under the x. So it's always this 5. This would be this 5 is the square root under that one. And 2, so it's always the one under the y divided by the one under the x. Both of these methods work. We have found all of our information. We are now ready to move to another one. Let's do number 3. Number 3, I want you to notice now the x is in the front and the y is second. A squared is still 4 and b squared is now 16. So we have a being the square root of 4, which is 2, and b, which the square root of 16 is 4. This helps us find our box. But the a value is on the x-axis this time. So it is on the x-axis, and that is 2 here. And 4 on the y-axis because it's under the y. Now we're going to draw our box. Now we can draw our asymptotes. They go from the center through the corners With your ruler, you can just make one long line. And now we need to decide, does our hyperbola go up and down or left and right? And we look at the one that's first, and since it's x is first, we go through the x-axis. So it's left and right. Our vertices are here on either side of our box. They're the numbers in front of the x in this case, underneath the x squared, and it's 2. And so we were going to the side, left or right, 2. So our vertices are plus or minus 2 comma 0. Let's find our foci next. We use the equation a squared plus b squared equals c squared to find that. Our a squared value is 4. Our b squared value is 16. We got that from either squaring our a and our b, or we got that from just looking at the bottom down there. That is 20. 20 equals c squared. When I take the square root of both sides, I get the square root of 20, and I can divide that into 4 and 5, which that is a perfect square root of 2. So I'll have 2 square root 5. That is a plus or minus since we did take the square root of both sides, and that actually makes sense because we have one on both sides. We have one here at these spots here, and 2 square root 5, when I put that into my calculator, is almost 4.5, so that's why I came out here about 4.5 on each of those. So my vertices are plus or minus 2 square root 5 comma 0. Now my asymptotes always have a y equals, always have a plus or minus, and it's some slope x. And that slope, I can find that a couple ways. I could just come down over here. That y value right there is 4. And this value over here is 2. And so we do our rise over our run, which is 4 over 2. We could have done the square root of the number under the y divided by the square root of the number under the x, which would be the same here, which is 2. So my slope is 2. Y equals plus or minus 2x is my equation. I have found everything I needed for this problem. Let's move on to the next one. Number 5 is not in the standard form. We must get it there. So I'm going to move this over here, 16x squared minus 25y squared, and I'm going to move that 400 to the other side. So we can start making it look similar to the standard form. Remember to look at your note sheet so we can see what that is. If you remember, 400 is not supposed to be on that side. It's supposed to be a 1. So I'm going to divide by 400 on both sides. Here on the right, it becomes 1. And 16 goes into 400. How many times? If you need to do that in your calculator, go ahead and pause. 16 goes into 400 25 times. So we'll have x squared over 25 minus y squared, and 25 goes into 40 16 times. So this is my a squared value, and that's my b squared value. So a equals 5 and b equals 4. This will help us find our square. The a value is underneath the x, so we're going to go on the x-axis. 5. And the b value is under the y, so we're going to go on the y-axis. Now we're going to draw our box. Now we're going to draw our asymptotes. Next and last, we're going to draw our hyperbola. So do we draw that up, down, or do we draw it left, right? Well, a is underneath the x. that means we draw it on the x-axis. So here is our hyperbola. So we can now put our direction of opening at being left-right. Our vertices are here. Our vertices are at our a values, and those a values are plus or minus 5, 0. Let's find our vertices. Our vertices, we're going to use the equation a squared plus b squared equals c squared. We can use our a and b value there, or we can use our a squared and b squared values there. We're going to have 25 plus 16. When you add those up, you get 41. We're going to take the square root of both sides. We'll get the square root of 41. We'll get plus or minus the square root of 41. The square root of 41, we're going to put that into our calculator. Pause the video now and put that into your calculator and find what square root of 41 is. I got 6.4, and so we're going to come over here and find that 6.4 value. We're going to have 6.4. I'm going to put a dot on each end. 6.4. So our foci are at plus or minus square root 41, 0. Our asymptotes, we can find those by taking the square root of the number under the y, which is 4, and the square root of the number under the x, which is 5. We always have an y equals plus or minus, and we always have an x at the end. We could have also found that with our equation that we have on our note sheets, but we can also do our little triangle right here. And the rise over the run, the rise here is 4, and the run there is 5. That's how we got the 4 over the 5. We have found everything we're supposed to. Let's move on to something else. All right. Let's look at ways that we can shift these parabolas. They will not always be on the x-axis. What I want you to do is right now look at your note sheets. On your note sheets, there's some things turned around. I would like you to fix them on your note sheets. The ones on your screen here are correct. We have 2 of them. The first one here has the x in the front. The second one has the y in the front. They all have a at the beginning. I want you to notice that we now have an h and a k. We have seen this before in all the equations we've done so far. We've seen this in parabolas, circles, ellipses, and now hyperbolas. And the center is at h, k. Now we need to decide which one's the horizontal one and which one's the vertical one. Since x is listed first, and when we were doing our ellipses and hyperbolas, when the x was listed first, we were on the x-axis at some way. So that is horizontal. When we had y listed first, they were either up-down for ellipses or the same up-down for hyperbolas. So this is our vertical equation. I would suggest that you write the word horizontal and the word vertical underneath there for your notes. Let's do number 7. I want you to notice that 7 is not at the center. We need to take the opposite of this number and the opposite of that number to find our center. Our center is at -3, -1. Our a value is always listed first, and our b value is listed second. So we take the square root of 4, which is 2, and we take the square root of 16, which is 4. And all 3 of these things will help us find our box. So we're going to come to the center of -3, -1, which is right there. The a value comes from the center, and in this case, It goes up because y was listed first. So we're going to go up and down 2 from there. Now we're going to go over 4 on each of them because our b value is 4. 1, 2, 3, 4. And 1, 2, 3, 4. Now we can draw our box. Now we'll draw our asymptotes. Our asymptotes go from the center to each corner, or from corner to corner. Now we need to decide if our hyperbola goes up and down or left and right, and we look at that y value that's first. The y value says that it's going to be a vertical graph, and that means it's going to go up and down. This answers this question, that this is an up-down hyperbola. Now let's do our vertices. Our vertices are right here. The first one is at -3, +1. The next one is going to be down here at -3, -3. Let's do our foci next. Our foci will be using the Pythagorean theorem. A squared plus b squared equals c squared. Our a squared value was 4, and our b squared value was 16. Add those together to get 20. The square root of 20, which we can take some pieces out, which is 4 times 5. So the square root of 4 is 2. So that becomes 2 square root of 5. That equals c. I want you to pause the video and find 2 square root of 5. Come back when you've got it. When I did it on my calculator, I got approximately 4.5. So we're going to go 4.5. Remember, that's 4.5 from the center. So we're going to come up 1, 2, 3, 4.5. And we're going to come down 1, 2, 3, 4.5. Let's find those ordered pairs. So we started off at -3. We started off at -1, and we're going up 2 square root of 5, and we're going down 2 square root of 5. So our foci are at -3, comma, -1 plus or minus 2 square root of 5. I have decided that on any of the ones where we're shifting, I have exempted you from finding the asymptotes. So we are finished with this one. We have found all of our information. We're going to move to the next one. Now we're going to work backwards. I am going to give you information and you're going to find the equation. I have given you the vertices and the endpoints of the conjugate axis. I like to draw these points on an axis. And it says that it's at 0, comma, plus or minus 1. So 0, comma, plus or minus 1 is up here. And the endpoints of the conjugate axis are at 9, 0, and -9, 0. The vertices are the a values, so a is 1. The conjugate axis are my b values, b is 9. Since my vertices are here on a vertical, that means that y is listed first, or it's on the y-axis. So that means our y is going to be listed first. For hyperbolas, the a squared value is always listed first, and 1 squared is 1. Then the b squared value is next. 9 squared is 81. you do not have to list the fraction line or the 1. We have found our equation. Let's move on to the next one. Number 17, I always like to draw a little sketch on the side. My vertices are at 3 and -3. And my foci is 5 and -5, which is right out here and here. My vertices are the A values, and my foci are my C values. But I don't have a B value. But we can find the B value by using the Pythagorean theorem. 3 squared is 9. B value is what we're looking for. And C squared is 25. Subtracting that over, I'll get B squared equals 16. So B is 4. So now I can find my equation. Since it is a horizontal hyperbola, that means that the x value is listed first. A is always listed in the denominator first. A squared is 9, and B squared is 16. I have now found the equation for my hyperbola. Let's do number 21. Number 21, again, I like to draw a little axis there. This time, we have our vertices are at 6, 3 and 4, 3. That means that our center is between the two vertices. So this halfway between 4 and 6 is 5. So my center is at 5, 3. We need to put that in there for our equation. Is this going to have x squared at the top or y squared at the top? Well, my vertices are going horizontal. We will have an x value first. So we will have x minus 5 squared, because the opposite of the 5 is -5. Next, we'll have a y minus 3, because the opposite of the 3 is -3. But what goes in the denominator? Our a value is going to be 1, because the distance there is 1. We are now told that the perimeter of the central rectangle is 32. So let's draw a rectangle. I just connected the vertices there. And I put that it was 2 at each one. Because it's 2 at each one because that distance is 1 and 1. And the distance between 4 and 6 is 2. But that means, since the whole perimeter of the rectangle is 32, and 2 plus 2 is 4, that I have 32 minus 4, which that makes 28. That means I have 28 to split between the other two sides. That means each of those sides is 14 and 14. But I'm looking for the b value, which is right here. And that is half of the 14, which is 7. So my b value is 7. I'm going to put that a value down here at the bottom to be 1. And 7 squared is 49, so I'll put the 49. I do not have to write that denominator. I have found the equation.